The basis is it's like Tailscale, but for 9P. That is that you do the so IoT world, they're trying to do REST. It's none of it is really secure. You still have to come up with conventions and have the namespace exposed through REST. So trying to, if you want to have a sane way of controlling remote devices, you establish through REST, and now you got to run a little web server on this unsecured IoT device, et cetera, right? And you're still trying to create some sort of a hierarchy that starts with HTTPS, or hopefully. But the idea is to essentially have everything client initiated or endpoint initiated, edge initiated. Most of those, at least in, let's say, using embed TLS, for example, they do support TLS 1.1, 1.2. Not great, but if it's edge initiated to a central point with key exchanges, you can sort of, or pre-shared essentially keys, you can have some guarantee that you can verify that the client is connecting to the central server where you have more control, is at least generally who they say they are. And then once that client connects, you establish the 9P connection. And the 9P connection at that point, the client side becomes the file server. And then you start serving the namespace of whatever device your PyPico is controlling a bunch of relays. You're exposing that as a file system, and the central point then can mount those or expose them to other entities down the line. So the other part of this is that central point is both for identity verification as of the edge devices, but also for users that own those edge devices. And that central point, you also, so that would be for the end users, would be through things like OpenID Connect. That central point can also then act as the stun turn. The essentially use Tailscale's derp server. And now you can do the hole punching through NATs, and Bob's your uncle, and that's it. All we need now is some code. It's done. It's already done.